Okay, so let's unpack this. We are looking at a piece of technology today that has a name that honestly sounds like a smoothie ingredient.
Or maybe a rejected Mario Kart character.
It's called Nano Banana 2.
Which, definitely doesn't sound like a serious weapon in the AI arms war, does it?
Not even close. But despite the totally disarming name, the sources we have today, ranging from technical papers to these really detailed developer benchmarks, they suggest this is actually Google's most aggressive move in the image generation space to date.
Oh, absolutely.
And it officially dropped just a couple of days ago, around February 26th or 27th, 2026.
Right.
So the reason we're dedicating a deep dive to this today isn't just the funny branding. It's because this model is trying to break a very specific rule that I think we've all just accepted about AI engineering at this point.
Yeah, you're talking about the iron triangle, or the pick two rule.
Right. Could you break that down for everyone listening?
Sure, so it's a fundamental concept in engineering generally, but definitely in AI deployment. You essentially have three corners: speed, quality, and cost.
Okay.
And the rule says you can only pick two. So if you want it fast and cheap, it's going to look terrible, you'll get low resolution, bad artifacts, you know the deal.
Yeah, the weird extra fingers and blurry background.
Exactly. But if you want it high quality and fast, you're going to need massive compute power, so it's going to be incredibly expensive.
But Nano Banana 2, which we should probably clarify for the listeners, is just the internal code name for the Gemini 3.1 Flash image model.
Yes, the official name is much more boring.
Much more boring, but it's claiming to give us all three. It's promising pro-level fidelity at flash-level speeds for literal pennies.
Exactly. It's basically claiming to be the proof that unicorns exist: high fidelity, low latency, and what the sources are literally calling price butcher economics.
Price butcher. I love that term.
Yeah.
So our mission today is to figure out if that's actually true or if it's just, marketing fluff.
Right.
We're going to look at the benchmarks that are supposedly impossible to pass. The features that might finally fix the massive headaches creators have been dealing with for years. And of course, the catch. Because there is always a catch.
There is always a catch. But to really understand the hype here, we have to start with those benchmarks. Because usually when you hear the word flash in the AI world, you automatically assume it's the dumb but fast version.
Yeah, you assume it's a distilled, smaller model that sacrifices brain power for speed. Like you use the Flash model for a quick meme to send to a friend, not for a client presentation.
Precisely. But I was looking through the testing notes, and Nano Banana 2 is passing the wine and clock test.
Which, I have to admit, sounds less like a technical benchmark and more like a riddle you'd hear in a pub.
It really does. But it's actually a bit of a legend in the developer community right now.
Yep.
It's considered a sort of visual Turing test for image generators.
Okay.
The prompt is deceptively simple. You just type a clock showing 11.15 and a wine glass filled to the brim.
Okay, let me play devil's advocate here for a second. To a human, that is an incredibly boring and easy request. Why does that make a supercomputer sweat?
Because it forces the AI to perform two very different types of reasoning simultaneously, and they often conflict with each other. First, you have the clock.
Right.
That requires strict spatial reasoning and the logic. The AI has to understand that 11.510 isn't just a label or a texture applied to a circle. It means the shorthand is physically pointing at the 11, and the longhand is strictly at the 3.
And historically, image models just sort of throw hands on a circle and hope for the best, right? Like, here's a circle, here's some sticks, good luck.
Exactly. They treat a clock like a visual pattern, not a mechanical device with rules. Then on top of that strict logic, you have the wine glass.
The filled to the brim part.
Right. That's a physics problem. It implies a specific liquid state, surface tension, and gravity. Most models will fill it halfway because that's what 90% of the photos in their training data look like.
Oh, because people don't usually photograph wine glasses filled to the absolute rim because they'd spill immediately.
Precisely. So the model actually has to fight its own training data, its own memory of what a wine glass usually looks like to satisfy the specific logic of the prompt.
That is wild.
And the reports are showing Nano Banana 2 just nails this. The hands on the clock are geometrically correct, and meniscus of the wine is right there at the rim.
So it isn't just memorizing pictures anymore. It's actually understanding the constraints of the request.
Yes. It's performing logical inference during the generation process itself.
Wow. And there was another one I saw in the notes, the glass burger.
Oh, yeah. This one is a classic for testing material assignment. The prompt is simply, make a hamburger made of glass.
Again, sounds simple enough, but I've definitely seen older models try this. They usually give you a normal burger sitting inside a glass box. Or maybe they make the bun shiny, but the lettuce is still, I don't know, leafy.
Right, that's a known issue called semantic conflict. The AI sees the word lettuce, and its internal weights pull heavily toward concepts like green, organic, and vegetable texture. Then it sees glass and thinks transparent and hard,
So it just panics and separates them.
basically. It struggles to merge those concepts for a single object. But Nano Banana 2 understands that the material assignment applies to the concept of the burger as a whole. So it generates the lettuce, the meat patty, the sesame seeds, but renders them all as if they were sculpted from solid glass.
Calculating the light refraction through all those weird layers.
Exactly.
So it's essentially doing ray tracing logic in its head.
In a way, yeah. It's decoupling the form of the object from the material of the object.
And here's where it gets really interesting for me.
Yeah.
It's doing this high-level conceptual rendering, this physics calculation, in, what do the sources say, 3 or 4 seconds.
That's the flash part kicking in. Compare that to something like GPT-4o image, which is obviously a fantastic model, but might take 60 seconds or more to churn out a high-fidelity image with that level of specific detail.
And Nano Banana 2 is clocking in at 3 to 4 seconds.
Every time.
How is it doing that? Is
Yeah,
it just
well.
cutting corners behind the scenes?
Mm-hmm.
Or is the Google hardware just that much better?
It's largely an architectural shift. As we mentioned, it uses Gemini 3.1 Flash as the core. The previous Pro models often used a very heavy thinking process where they would decompose the prompt, analyze every single word, plan out the image layout, and then generate it.
A very multi-step heavy compute process.
Exactly. But Nano Banana 2 skips those deep thinking steps. It generates directly via a diffusion model, but it uses a massive amount of training data, essentially real-world knowledge, to fill in the gaps that the thinking process used to handle.
So instead of stopping to calculate what a glass burger should logically look like, it just intuitively knows because it has better access to the underlying data.
That's a really great analogy. It's moving from deliberate calculation to intuition, if we can anthropomorphize it a bit. It's just incredibly high throughput inference.
Okay, so it's fast and it's smart. But for anyone listening who has actually tried to use AI for real work, not just making funny pictures of cats, the biggest problem isn't getting that first image. It's getting the second image.
Ah, yes. The shape-shifting problem.
Exactly. You generate this really cool character, let's say a detective in a trench coat. It looks amazing. Then you ask the AI for that same exact character in a different pose, or maybe sitting at a desk.
And suddenly they're wearing completely different clothes.
Their hair changed color, and they've somehow aged 10 years. It makes actual storytelling basically impossible.
And this is where Nano Banana 2 seems to be targeting the creator economy directly. The spec sheet says it can maintain consistency for up to 5 distinct characters and 14 objects within a single workflow.
Wait, 5 characters at the same time.
At the same time, Google's demo showed a prompt of 3 fluffy friends building a treehouse and later another one with 14 characters having fun on a farm. Yeah. You can basically generate a full sequence, like a storyboard or a comic book, where the characters actually look like themselves in panel 1, panel 2, and panel 3.
That is a total game changer for storyboards, or even just pitching creative ideas to a client. You don't have to keep saying, hey, imagine this guy actually looks like the guy in the previous slide. He just does.
And it extends to objects, too. Say you're designing a product, like a specific type of coffee maker, and you want to show it in a kitchen, then on a dining table, then maybe outside on a patio. The AI keeps the object completely consistent.
So it doesn't hallucinate a new spout or a different handle every time you change the background?
Exactly. It creates a temporary, consistent identity for that object in its working memory.
Speaking of not hallucinating, we really have to talk about text, because AI spelling has historically been, well, distinct.
Alien gibberish is usually the polite term. Runes from forgotten dimension.
Right. But I saw this one example of a Windows screenshot in the source material, and it blew my mind.
Oh, that was incredibly impressive. The model generated a completely fake Windows desktop. It had a web browser open to YouTube, and it showed a specific thumbnail, a Mr. Beast video, and the text on the screen was actually readable. It looked exactly like a real screenshot.
So no weird symbols that look like ancient runic script.
Much, much less of it. Now, we should note it's not flawless yet. Users found some typos, like It's spelling Gemini 3.1 as Gemini 31.
Drop in the decimal.
Right. But compared to where we were just a year ago, it's a massive leap. It can handle text on blackboards, signs in multiple languages.
Wait, so if I ask for a sign that says Fresh Bakery in French, it actually writes the French correctly?
It translates it and renders it perfectly on the sign. And this is a big deal because it moves image generation away from just being art and turns it into an information utility.
Okay, explain that a bit more.
Well, you can now reliably make UI mockups for an app or infographics or educational diagrams with actual labels.
That distinction information utility is huge because it implies a level of accuracy we haven't seen. And that leads right into the world knowledge aspect that the sources brought up. They mentioned this model is connected directly to Google Search.
Yes, and this is critical. Most image generators are just dreaming based on loose patterns they learned during their initial training run. But Nano Banana 2 is grounded.
Grounded in search data.
Right. So if you ask for a water cycle infographic, it doesn't just make a pretty picture with some random blue swirls. It actually understands the scientific concept.
Oh, wow.
It puts the arrows flowing correctly from left to right, evaporation up to condensation, then precipitation. It knows the underlying logic of the system it's drawing.
Or logos. I saw it knows exactly what the Netflix logo looks like.
Or the GTA 6 logo. It's pulling from real-world, real-time recognition. It's not just imagining a generic streaming service logo. It knows the specific brand identity if you ask for it.
That brings us to editing. Because let's be honest, getting the initial image is only step one. Step two usually involves taking it into Photoshop because the AI messed up a hand or the lighting is weird.
Well, Nano Banana 2 is introducing what looks like a digital scalpel. They technically call it in-painting, but it's incredibly precise.
The example I saw in the deep dive sources was the suit.
Right. So imagine you upload a photo of a man wearing a formal business suit. You tell the AI, change the jacket to leather and remove the tie.
In the past, the AI might have just redrawn the whole person or entirely messed up the background behind him.
Exactly. But here, it keeps the pants, it keeps the exact pose, it keeps the complex background pattern, and it just surgically swaps the jacket.
And it matches the lighting.
That's the real key. If the sun is hitting the man from the right side, the new leather jacket has accurate highlights on the right side. It deeply understands the environmental context.
And then there's outpainting.
Which is the exact opposite. You take a close-up, say, just a coffee cup, and you tell the AI, show me that this cup is actually sitting on a table in Paris near the Seine River.
So it expands the canvas outward.
It expands it and invents the table, the river, maybe the Eiffel Tower in the distance.
Yeah.
But it integrates the original lighting of the cup perfectly into that brand new environment.
It's like having an infinite camera lens that you can zoom out with after you've already taken the photo.
Precisely. And it's doing all of this at 4K resolution.
Native 4K, right. Not just a low-res image that's been upscaled.
Native 4K. And with flexible aspect ratios, you aren't stuck with just squares anymore. You can do 16 by 9 for video backdrops, 21 by 9 for cinematic shots, 1 by 1 for social media.
Nice.
And it doesn't just crop the vital details to fit the box, it recomposes the entire image to fit whatever frame you choose.
Okay, we have to talk about the price. We started this whole discussion talking about the iron triangle: speed, quality, cost. We've covered the speed, which is 3 seconds. We've covered the quality with the glass burgers and perfect text. Now, cost.
Yes.
Usually when you hear native 4K, 3-second generation, perfect text, you assume it costs an absolute fortune to run.
But the sources are calling this Google's price butcher strategy.
How cheap are we actually talking?
If you access it via third-party developer platforms like API, the cost is hovering around 3 cents per image. Even the official Google pricing for 1K resolution is about 6.7 cents.
3 cents.
3 cents. To put that in perspective for you, that is roughly 50% cheaper than the previous Nano Banana Pro model. And if you compare it to GPT-4o image, it's about 1/5 of the cost.
So for the price of 1 image on a competitor's platform, I could generate 5 on Nano Banana 2.
And that completely changes user behavior. Think about it. If an image costs 20 cents or takes a full minute to generate, you are precious about it.
Right, you spend 5 minutes crafting the absolute perfect prompt so you don't waste money.
Exactly. But if it costs 3 cents and takes 3 seconds, you just spam the button. You treat the AI like a sketchbook.
It becomes a sort of brute force creativity. You just keep hitting generate until you see something you intuitively like.
Exactly. It drastically lowers the stakes of experimentation. You can afford to have 50 bad ideas just to find the one really good one. It democratizes the entire trial and error phase of design.
But, and here is the but, there has to be a downside.
Mm-hmm.
We talked about the catch earlier. Google is known for being, let's say, very cautious with their public releases.
Cautious is definitely putting it mildly. The guardrails on Nano Banana 2 are incredibly strict. If the early days of AI art, like the Stable Diffusion 1.5 era, were the Wild West, this model is a high-security facility.
So what can I do with it?
While public figures are fully blocked, you absolutely cannot generate a picture of a politician, a celebrity, or any real famous person.
Even if it's totally harmless, like if I just prompt the Pope riding a skateboard.
Fully blocked. They are terrified of deepfakes and political misinformation. They simply do not want their tool to be the source of the next viral fake news photo.
Which makes sense. What else is blocked?
They've also added some very specific blocks for financial documents.
Oh, is that because of the text rendering upgrades?
Exactly. Since the model is now so good at rendering realistic text and UI elements like that Windows screenshot we discussed, it could theoretically be used to forge bank statements or invoices or realistic screenshots of wire transfers.
Wow, yeah.
So they have put in specific filters to prevent modifying or generating financial info to stop fraud before it starts.
That makes a lot of sense. It's the dangerous flip side of being an information utility. If you can make a perfect mock-up invoice, you can make a perfect fake invoice.
Right. And to add another layer of security, they are also using Synthi, which is an invisible watermark embedded directly in the pixels, plus C2PA credentials.
So any platform that actually cares to check will know immediately that the image is AI generated.
Exactly. So no passing this off as your own authentic photography in a contest.
Well, you can try, but the digital fingerprint is permanently there. Are there any other flaws we should warn people about, aside from the nanny filters?
It is still technically in preview mode, so reliability can occasionally vary. We mentioned the text isn't 100% perfect, yet typos definitely still happen. And for developers or heavy users, the free tier for the API has been severely slashed.
Oh, really?
Yeah, Google quietly cut those free API quotas back in December 2025. So if you want to play with this at scale and build an app, you are going to be paying that 3 cents.
The classic drug dealer model of tech. The first ones were free, now you got to pay.
To be fair, at 3 cents, it's a very cheap habit. But for a startup building a product entirely on top of this API, that massive volume cost is a real consideration.
So pulling this all together for everyone listening, we have a model that is fast, incredibly cheap, understands high-level concepts like glass burgers and claw cans, and can actually keep a character consistent across a long story.
It really feels like a definitive shift from AI as a toy to AI as a reliable production tool. When you finally solve the consistency problem and the text problem, and you make it fast enough to be real time, you open up applications we just haven't seen yet.
Like what? What's the killer app for this going forward?
Well, it's already the default engine in Google's Flow tool, and it's heavily integrating into Google Ads right now. Imagine you are running an ad campaign. The system doesn't just suggest a text tagline anymore. It generates 20 variations of the visual, fully rendered, with your actual product placed in different lifestyle contexts in seconds for pennies.
Giving you custom-tailored ads for almost every single person who looks at them.
Precisely. Or think about video games dynamically generating textures or background assets on the fly as you play. Or e-commerce showing a shirt-on models of every different body type and size instantly, without a photo shoot.
It's incredibly impressive, but also, honestly, a little overwhelming.
It is. It accelerates the content cycle to a speed we really aren't used to as a society.
You know, before we wrap up today, I've just been thinking about that price point. 3 cents and 3 seconds.
It's a race to the bottom in a way.
It is. And it makes you wonder, we are entering an era where a photorealistic 4K image is basically as cheap and disposable as a text message.
We send texts all day without even thinking about them. We're about to start sending entire worlds without thinking.
Exactly. When visuals are instant and infinite, what happens to the value of human observation? If I can generate a perfectly lit 4K sunset over Paris in 3 seconds, does it matter less that I actually went outside and saw a real one?
That is the ultimate question here. When perfection is that cheap and easy, maybe the flaws of reality become the new luxury? Or maybe the act of capturing something real becomes more valuable specifically because it wasn't synthesized in 3 seconds.
Definitely something for you all to think about next time you see a glass burger on your timeline. Thanks for listening to this deep dive into Nano Banana 2.
Thanks for having me.
We'll see you next time.